The use of plant-based cellulose in brand new applications has the potential to alleviate many environmental issues caused by fossil-derived chemistry. In a groundbreaking research effort, Professor Rodrigo Serna's team at Aalto University is developing green chemistries to tackle some of the major environmental challenges of the mining industry.
One of the main techniques that we use in our laboratories is called froth flotation. Froth flotation is the operation that is used by the largest number of mines in the world to concentrate minerals.
Most of the frothing chemistries in use are oil-based, and some are quite toxic. Professor Serna's team has successfully studied a cellulose-based biodegradable alternative.
It is cellulose that has been treated chemically in a way that it has very, very specific characteristics. We have tested this cellulose chemistry in our labs, and we have managed to improve the performance of flotation. We are producing more minerals, and we are producing them faster. This means that we are capable of improving the overall productivity of any processing plant using sustainable chemistry.
But what exactly happens in the flotation process?
So what happens in a flotation cell is that we take the ore and water and we mix it together. Then we blow air bubbles through the whole slurry mixture. And within this slurry, bubbles and mineral particles, they collide, and then because of the chemistry that we use in the flotation cell, the valuable mineral particles attach onto the bubbles, and then the bubble's buoyancy will lift up the bubble particle aggregate to the top of the flotation cell, where it forms a mineralized froth, which is then collected as the product of the separation process.
In addition to utilizing renewable raw materials, the cellulose frother has two distinct advantages over current chemistries.
First of which is it has a self-stabilizing property, which means that the foams and froths produced by the cellulose are stable by itself, whereas with normal frothers, you need the mineral particles that are sufficiently hydrophobic so that they help stabilizing the froth. The other advantage is that in our bubble size measurements, we have noticed that this cellulose enables the creation of even smaller bubbles. And when we have smaller bubbles, it means we have more bubbles, and then we have more bubble particle collisions. So then the probability of successful separation taking place is higher.
In a recent Business Finland project, the team was able to prove the concept in real-life conditions.
And we did this in a continuous mini plant setting. We took real mineral and we tested a smaller scale process that nevertheless included all the steps that are found in a real processing plant. And we demonstrated that we are capable of producing more material, more minerals with our chemicals in a faster manner.
Furthermore, the process has been tested on a variety of minerals.
We have tested, for example, the production of copper. We have tested the production of zinc. We have tested the production of gold. All of these have produced very positive results. But froth flotation is used in many other minerals processing. So we believe that we may find the right formulations for all other minerals, including, for example, platinum group metals or even industrial minerals for construction, for example.
This new technology has the potential to improve the productivity of mineral enrichment processes while simultaneously reducing the environmental impact. And best of all, the increase to process expenses would be minimal.
There does not need to be a compromise between sustainability and performance. I strongly believe that by carrying out strong and clear science, we can find new technologies that will help us in both directions.